you so much for this second challenge from Adrien. So we're looking at lateness of students at the prep school for this challenge. So if we take a look at our data, then what we have is basically information about when a student scans in their card for their arrival. They're always supposed to arrive at 8 a.m. Every day, and we have their actual arrival times here as well. So you'll see, first of all, we can kind of see down the table here, there's a null in the arrival time. We can see over here that we have some null rows, and the challenge tells us that we can assume that these are when the student wasn't present. So they didn't come in at all that day, maybe they were sick, that sort of thing. So we can exclude these from our analysis of lateness and only think about the days that they actually did come in. So that's what we do in this first step. And then we're looking at the scheduled arrival time, we're looking at the arrival time, and we're noticing that because these fields only had time components in them, Tableau Prep gives it like the default time, or default date, sorry, to be associated that with time, because Tableau doesn't have its own time data type. It only has date or date time. So we need to just basically replace the date here, overwrite that default date with this date in this field instead. So that's what we'll do next. So luckily we can use the make date time function. So the date is coming from the date field and the time is coming from the scheduled start time. So that basically is then going to ignore the date that is currently in the scheduled start time field and just overwrite that, which is wonderful. So now we can see that our scheduled start time is matching up with the date here, with just 8 a.m. every day, and then exactly the same thing again in the arrival time, so just overwriting the date in the arrival time with that date field itself. And then now that that information is within each of these fields, we don't need that additional date field anymore in our data. So now we have the information necessary to be able to calculate the arrival time, or how late each student was. So we can do a date diff function. So we're using the minute here. One thing that I always remind people of when I'm teaching about prep is that anytime we need to put a date part into a function, make sure that it is all lowercase, that it doesn't have an S on the end of it. So if this said minutes, then this function wouldn't work. So we need to make sure it's always a singular lowercase so that that date part gets recognised in the function. So we're doing counting the number of minutes between the scheduled start time and the arrival time of the students. And we can see that obviously if they were early, so they arrived before the start time, then they get a minus number. If they are late, then it's a positive number there. And we have two outputs required for this challenge. So first of all, for our first output, we need to know what the average lateness was on each day of the week, so that the principal can analyse, is it a certain day of the week where most of the lateness is happening? And it's seeming like that might be the case actually. For example, here the 16 goes with Monday. So the reason when I clicked on that and it didn't filter below is just because it's a very precise number. Sometimes trying to filter doubles doesn't work quite well because of like the floating point error. But it looks like Mondays basically are the days of the week where people are most likely to be late. So maybe the principal will be able to make some decisions based on that finding. So we're just going to then apply a ranking to the lateness. So we want to know the day with the most lateness is a Monday. It gets a rank of 1 there. And then we're just passing this information, rather than it being that long decimal number, can that be translated into seconds instead? And so we do a little bit of calculation for our minutes and seconds. So the minutes part is just removing any of the decimals, and that will be our minutes. So using the floor function there to just get out that whole number part. And then our seconds can be calculated by doing the lateness, so this decimal field, minusing off that minutes part that we just created, so we just have the decimal part left, and multiplying that by 60. And then we're just rounding that, wrapping that in a round function so it is a whole number, so that we now have, rather than 16.48 so on and so forth. We know that actually just translates to 16 minutes and 29 seconds. So we can read that a bit more easily as humans. So that's our first output calculated. We just remove that original lateness field there. For the second output, we're looking a bit more at the students themselves. So we're classifying that anyone who is over 5 minutes late is very late. So just creating a quick calculated field to say if that lateness is greater than 5, then 1, else 0, so that we are able to count how many times each student has been very late. So we're grouping by the student ID, we're summing up our very late field, so it will count the number of days the student is very late, and we are also summing up the number of rows, so we know the total number of days that the student was present at the school, so that we can calculate a quick percentage. So we're just renaming our number of rows to number of days present, so that's easier to keep track of. And then we are calculating that percentage as the very late days divided by the number of days present and rounding that to 1 decimal place. So we have this percentage value there. So we can see then that it is student number 5 who is late the most, over half of the time. Terrible. And again, we're just using that rank again on the percentage days very late, so that we have that in order for our output. So thank you very much for this challenge, Adrien. Very interesting to work through, and thank you very much for watching.